I think I know more than you do, but I think it's part of it. All right. Here we go. Everybody's got your practice quiz, so we are going to go through this. This is our practice quiz that we are going to have the next time we meet, which is Thursday. We will have a quiz, and it will look like this. It will have 3 problems on it, and hello, good to see you, Precal survivor. All right, so number 1 is a review of the quiz question you had today. So let's go through that. I don't know how you did on today's. We'll get those back tomorrow before we take this one, though, so you can see if you made any mistakes on this problem. We want the vertex, axis of symmetry, and direction of opening. Okay? Okay, you weren't even here at the beginning. Where were you?
I thought I had dictator. I forgot, and then I came here, but the door was locked. Okay,
so what did you do during the whole A period? Did you go to lunch A period?
Yeah.
Okay, well, Matthew's in the middle, so you need to be here from now on. And where were the rest of you?
Lunch.
Mason, and who's the other one that came in late? Evan? You guys just what?
Lost track of time.
Oh, Marco. Don't do
Peyton, tell them what happens if you don't bring in your Kleenex.
Hang on.
All right, so here we go. We're going to find the vertex. Jalen? We're going to find the vertex, axis of symmetry, and direction of opening for this. Now, gang, how do we do that? How do we do that? You got some options, but the easiest option is negative b over 2a. That is going to be your axis of symmetry. So in our problem, what is b? What is b?
A.
B is negative 8. So negative b will be 8 over 2a, which will be 4. So your axis of symmetry is x equals 2, which means your vertex has an x coordinate of 2. So then how do we find the y part?
Plug it in.
We come back up here very carefully. So we have 2 times 2 squared minus 8 times 2 plus 3. When we do 2 times 2 squared, it's 2 squared times 2. So this is 8. Minus 16 plus 3, which adds up to negative 5.
Can you do that way slower? Because they got lost.
Okay. Come see me during flex. And then what's the direction of opening?
Up.
Up. Because it's always up when this number is a positive. Yeah. Okay. Now the next one. We talked about this yesterday, so let's see what you remember. Volume varies inversely as pressure. So remember, there are 2 variation formulas. One would look like, in this case with volume and pressure, one would look like V equals Kp, and one would be V equals K over P. Those are your 2 choices. So which one is it? It's the second one. And why is it the second one? Inversely. This is the inverse relationship. This is the direct relationship. So this is where I'm starting. Now it tells me when the pressure is 10, the volume is 60. So this is my format, and then it says when the pressure is 10, the volume is 60. So K equals 600, which means my formula is V equals 600 over P. So then I can answer the question. Find the volume when the pressure is 600, or excuse me, 16. Right? So then I can either reduce that fraction or type it in on my calculator. What is that decimal? 37.5. So the answer is 37.5. Okay? So to do that problem, you have to remember you've got a direct relationship and you got an inverse relationship. One of those is going to be the formula you're going to use in the problem. Then plug in what you know and you'll figure out what K is, and then you can answer the question. And then the last one, that's our sketch. So you know what to do here. First thing you're going to do is put the dots on the number line, or on the coordinate plane. And where will the dots go?
-3, -1, and 3.
-1, 3, and -3. Remember, the parentheses give you the dots. The parentheses, the x quantities give you the dots. How many x's do we have in this problem? 5? 5 is odd. Odd means start down and up. Except there's a negative out in front, which means I will start up and end down. So I'm going to start up here. Now when I get to this point, I have to make a choice. I'm either going to go straight through, squiggle through, or bounce off. What is it at this point? That's that factor right there. Pay attention, -3 comes from this factor, so that's going straight through. And connecting to the next one. What's it do when it hits the next one? Bounces off because of this. So that's going to connect to this one. What's it going to do when it hits there? Bounce off. And down it goes. So there is a picture of your curve. So this is the quiz tomorrow. Okay, remember, you do have homework problems that most of you don't do, but you could do those for extra practice. Quiz is Thursday, yeah. Okay. Now, back to our notes, because we got to move ahead here. Back to our notes. So the quiz on Thursday will be these 3 problems in some order.
Is anyone want this bun of honey? Yeah.
Now, we are on page 17 and we are looking at number 3. The directions say sketch. Uh-oh. What's different? We just sketched one. You guys are pretty good at it. What's different about this?
There's no parentheses.
There's no parentheses. Are the parentheses important?
Yeah. No.
Yeah?
Yeah.
Because what do the parentheses do for me?
Make us points.
Give me the dots, right? Those are my x-intercepts. You can't get started here, kids, if you don't know where the x-intercepts are. And the x-intercepts come from the factors.
You just
So
distribute.
guess what you're going to have to do? You're going to have to factor this guy. And Corey and Francie are both saying the same thing. They're saying, can you split it up? Can you factor it by groupings? Zion's nodding. So what we're going to do is take the first two terms, and we've already practiced this in other problems earlier. Let's take the first two terms. What can we take out of those? An x squared. So that will be x squared, and then we'll have x minus 4. Now, what about the last two terms? Well,
Take out weighted distributed.
take out a what? A negative 1. And that would leave me, if I took out a negative 1, it would leave me with a positive x and a negative 4. Which is really good news because these two match. So I'm going to write down my match, and then I'm going to write down everything else. Now, what do we notice about that guy?
X plus 1,
X plus 1, x minus 1. Is this now factorable, or graphable for me? Yeah. Now I can put dots at 4 and 1 and negative 1. You don't even need to count. They told you in the beginning this was an x cubed problem. So x cubes are supposed to start down and end up, right? Are any of these squared or anything? So you're just going to connect them and zip right through. So here we go. Start down, end up. There it is. You just graphed a cubic polynomial that wasn't even factored for you. Good work. Guess what? There's another one. Let's look at the next one. Here we go.
For some reason I got x minus 4.
Nope, just take out the common factor. It's x minus 4.
Yeah. Oh, oh, I know.
Okay, let's try this one. Directions are the same thing. You gotta you gotta graph this guy. But in order to graph him, we need to get him factored, right? So we know where to put the dots. Shall we try the same thing?
Yeah.
So here we go. Let's put those two together. What does that give me? I can take out an x squared, and I will be left with x plus 3. Perfect. What about these last two? What can I take out of those guys? A negative 4, leaving me with, we took out a negative, so it'll be x plus 3. There's that common factor again, which is really good news. So we write it down. And then what's left is x squared minus 4. And what do you know about x squared minus 4?
How is x plus 3 not squared though?
Okay, Corey, if you have this, what's the common factor? Yep. It's x. It's not x squared. You take out the common factor. This is the common factor. That is like the x that I'm taking out. It comes out one time. What about x squared minus 4? X plus 2, x minus 2. Yep. Nothing is squared, so I'm just going to pop my zeros up here. Where does this start? It's another cube, so it's going to start down. And connect all the dots, no bouncing, just connect them, and we are finished. One more and then the fun begins. I mean, this is fun, but this is nothing like what's coming. How about this one? What do you think about this? Same thing. So from the first two, we can take out 2x squared. And what will we be left with? X minus 1. How about here? Minus 8, left with x minus 1. Remember, you took out a negative 8. So there's my common factor. I don't square it, I write it down. That's my common factor. Write it down. And then what's left is 2x squared minus 8. What are we going to do with that? 2x squared minus 8.
You gotta factor it again.
How does that factor? Oh, we can take a 2 out. I'm going to put the 2 out in front. And that'll leave me with x squared minus 4. And then that'll break down.
Stay factoring, bro.
X minus 2x plus 2. Now, when I put my dots on the number line, how many dots are there going to be? 3. Don't let that 2 confuse you. We really only pay attention to that 2 if it happens to be negative, right? Don't let it confuse you. So here's the 1, and the 2, and the negative 2. This is another x cubed. So it's going to start down here. Connect the dots. Done. So what do we do if we get a problem and it's not already factored for us? We factor it, right? And what do we try first? Try to factor it by grouping. Now, look at number 4. This is the first probably real stuff that we've done this year, real fourth year math. Let's look at the problem and tell me if you see what's wrong with it.
It doesn't come out the same way.
You can group it, right? You can group it. The first 2 you would take out an x squared. The second 2 you take out a negative 1. What doesn't happen that has to happen?
X plus 2 can't
They got to match. This problem does not factor by grouping. So you need another method of factoring. Alright, so here we go. You're not going to like it in the beginning, but after we practice a few times, you'll love it. What needs to happen if something is a factor? It divides in evenly. Would you agree with that? If it's a factor, like if I say 5 is a factor of 15, that means 5 goes into 15 evenly. 5 is not a factor of 12 because it doesn't go in evenly. So what we're saying is we need to find a number that divides into this evenly. Then I would have a factor. All right? So let's just pick a number like 1. I always start with 1. This is going to be a guessing game. And I always start with 1 because it's easy. Here is what we're going to do. Did you guys do synthetic division last year?
Yes.
So you know, if I'm going to divide by 1, it means out here in the box, I'm going to put a 1. And then I'm going to write 1, 2, negative 5, negative 6 across the top. Now, I don't know what the factors of this problem are. I am guessing 1. If 1 doesn't work, then I'll guess 2, or I'll guess negative 1. But I'm going to keep guessing until I do a division problem, and the remainder comes out to be 0. Because if something is a factor, and that's what I'm doing, I'm looking for factors. If something is a factor, it divides in evenly. So does everybody get these numbers right here? They're these coefficients, right? This is the number I'm guessing. Now, how does synthetic division work? How do I start doing this? Do you remember?
No.
You drop this number straight down. And Rylan, you're saying something about multiplying and adding, and you're right. We're going to multiply 1 times 1, and we're going to write the answer here, and then we're going to add. And then I'm going to multiply 1 times 3. I'm going to write the answer here, and I'm going to add. 1 times -2 is -2. Did I get 0? No. So I don't know what a factor is, but I know 1 is not 1. Right? So guess what? We're going to do it again. Let's try 2. Now you're thinking to yourself, oh my gosh, Mrs. Ford, you got to be kidding me. I am not. This is how we do it. That's how we do it. So here are my numbers again. I'm starting all over. Now I put a 2 out here because I'm guessing 2. Drop this straight down. 2 times 1 is 2. I'm going to add. 2 times 4 is 8. I'm going to add. Oh, you start to get excited. 2 times 3 is 6.
0.
And when I add, I get 0, which means that I have found a factor. One of my factors is x minus 2. This is the dot number. This is where the dot goes. So if the dot goes at 2, isn't my factor x minus 2? Now, how many factors should I have? 3? Now, I could keep guessing, but I'm not going to. Audie and Andy. This is the most exciting stuff you've ever done in your lives.
No, Audie, his eyes are open. He's reaching for his jeans right now.
Well, I'm actually reaching for it.
Think back to your synthetic division. Think back to your synthetic division. What does this stand for? Do you remember? After you've done the division, you remember what these numbers stand for? This is 1x squared plus 4x plus 3. Now, why is it x squared? Because the original was x cubed, and when I divide 1 out, it goes down by 1 power. I can tell some of you have forgotten how to synthetically divide, so we'll do more of this on Thursday, but let's finish this problem. So when I do the division, I'm left with these 3 numbers. Always the first one is 1 less than this power. So since that's x cubed, this is going to be x squared, because I divided 1 out. So I have x squared plus 4x plus 3. Now remember, you're trying to factor. Can you factor that? You can factor that. How does that factor? X plus 3 and x plus 1. So now we have our factors and we can sketch it. Our dots will go at 2, at -3, and at -1. That's our dots. Right? It's a cube. Up we go, connect the dots. Done. All right, the quiz on Thursday over what the practice was over, and then we'll continue this. We'll do some more synthetic division. Have a great day. I will see you Thursday. Hey, good tomorrow.